All right, my friends, welcome back to our class on certainty and probability theory. Last week, we started off with Jaynes. His book, Probability Theory. We got a full 3 pages into the book by examining, in a loose fashion, some very elementary ideas of logic, which I told you some people take as the epitome of all thinking, which I don't believe is true. And I'm going to start proving that to you today. We're going to use my book today, Uncertainty, and I'm going to have an excerpt of this stuff, the material that you'll need. It'll be on the blog post. It's either at my site, WMBriggs. I don't know where you're seeing this video, but it'll be on my site, WMBriggs.com or WMBriggs.substack.com. I'm going to start off in chapter 1 in my book, which is about truth. We talked about truth a little bit last week and uncertainty and so forth, but I didn't define any of those things. And we need to understand exactly what they are. So this is the title of today's lesson. The most infamous question ever asked. And it was asked not because the speaker or the questioner did not know the answer. He surely did. He had truth right in front of him. It's because he did not want to believe the result of his cogitations or his deductions and so forth. So we have to talk about that. That's going to lead us to the subject of necessary and conditional truths and so on. Now, we have to separate. We seriously have to separate academia. Here's a mathematical equation for you. Academia certainly does not equal, mathematical symbol for you, does not equal science or knowledge. Now, for a long time, there was a strong positive correlation. We'll talk about correlation and its sense of causality or non-causality when we get to that a long time from now. But there was a positive correlation between academia and science and academia and knowledge. That's out the window now. The correlation is now negative. And Alan Saber, you've seen this video. I'll probably put a link up to it. You've seen the video in which he is discussing the deficient thought of graduates of university, of academia, who are out in the field, and he wants to discuss what works. Why does this land keep its water, and why does this land lose its water, and so forth. And he says the students literally will not believe anything unless it's in a peer-reviewed paper. Well, peer review, again, was one of those concepts that had a positive correlation with knowledge and truth, which has now turned either no correlation and even some fields a negative correlation. So we need to make sure we're not understanding academia. We're not trying to understand papers. We're not trying to understand the behavior of scientists now. Because in science, in academia, what counts, of course, is bringing in money, prestige, but they also love to solve puzzles for themselves. So I'm going to read you this quote. This is, and they love skepticism, particularly in philosophy and so forth. They like to create these puzzles they call them problems, and then try to solve them, solve these questions that don't need solving. So this is a long time ago. This was 6 years ago, or more than that, maybe close to 70, 80 years ago. He wrote, and he was exasperated even then over the pretended puzzlement that academics have over what truth is or whether truth exists and so forth. He said the academy, in its dread, superstition, and dogmatic reaction, has been oriented purposely toward skepticism, and that a conclusion is admired in proportion as it is skeptical. That a jejune argument for skepticism will be admitted where a scrupulous defense of knowledge is derided or ignored. That an affirmative theory is a mere annoyance to be stamped down as quickly as possible to a normal level of denial and defeat. Well, that's the way it is in academia. That's not the way it is for us, okay? We're not trying to shore up any kind of academic sense right here. We're trying to get at truth. And truth obviously exists. Some people will say, they will say this. True Truth does not exist. They will say it is true. Truth does not exist. Jay, thank you very much for the idea about caffeine. It is not working. My screen still falls asleep, everybody. The problem is, long ago, this dumb laptop of mine, it had a problem. It was using too much power when the lid was closed and so forth. So I went in and monkeyed with the BIOS to make sure it shut itself off. And now it's shutting itself off. And I have to go back in and unmonkey it. But I haven't done that yet. So I have to keep popping over to that stupid computer. Anyway, they won't say it in quite this form, but they'll say, well, they'll write long papers in order to try to tell you that truth does not exist. Or they will say, it is certain there is no truth, which is another way of saying it. Well, we're interested in truth, and we're interested more. Obviously, we're always aiming for truth. Our intellects are aiming towards truth, but there's a lot of things in which we have uncertainty. Uncertainty and probability necessarily point towards truth. We're uncertain about a truth. We're uncertain about a proposition that may be true or false. If we knew it was true or false, we would say it's true or false. But we don't. We're uncertain. But in order to have uncertainty, we need to have an underlying truth. So truth certainly exists for us. So we're not gonna fart with that kind of thing too long. And the best definition, what do you want a definition? Well, you got to have a definition. Your common sense definition is probably good enough for most of this class, but we'll go back to Aristotle, rightly called the philosopher by the scholastics. We'll also call him the philosopher. Aristotle's definition: to say of what is that it is not, or of what is not that it is false, while to say of what is that it is, or of what is not that it is not, is true. Simple as that. Naturally, academics came along later and they have to give a label for this very common sense view. They call it the correspondence theory of truth. Well, we can eliminate that theory. It doesn't make any sense because all theories are judged by this sort of dichotomy of true or false, the Aristotelian division of things in true and false. And there's even in mathematics, they have this, there's a subject called logic, which is treated with the true-false binary, if you like. But they have all kind of other logics where they invoke different numbers of conditions, not just true, false, but there could be 3, there could be 4, there could be more. But it's funny, in all the proofs of all these kinds of things, in order to prove these theorems about this and that correspond to all these things, they still use the binary true or false theory to prove these theories within in these multi-valued logic sort of things. So no matter what, we can't escape it. All right. I'm not going to go on and on about that any more than that. I think that's exactly what it is. And we're going to talk about eventually realism. We're going to hold with the philosophy of moderate realism, which is to say the external world exists and we can know things about it. It's as simple as that. All scientists are realists in this way, but there's all kind of shades to that, which we'll get to. We don't need any more than that today. In mathematics, though, there is the idea of nominalism, that people believe that numbers are just creations. Our theorems are just creations, just products like an artistic fever dream, if you like. I don't hold with nominalism. I hold also in mathematics. There's an Aristotelian sort of realistic approach to mathematics too. It's not as well known. There's sort of a Platonic version which is similar, that a lot of mathematicians hold numbers are real and they exist in some kind of empyrean. That's almost right. I think the Aristotelian version is better, and which we'll get to. Jim Franklin's got a great book on that. I don't know where it is at the tip of my fingers, but James Franklin, you look it up, the Aristotelian philosophy of mathematics or something like this. All right. Well, there are truths. That much I think is probably agreed to by all of you. But can we know truths? And I say, yes, If you disagree, you agree. If you say it is certain, I know it's a fact, we can't know any facts, well, you've just created a fact which you say you know. So you have contradicted yourself. So yes, we can know truths. And in fact, in philosophy, usually we keep this word. Look at this dumb thing. If I'm staring at it when it happens, I can catch it. But if I'm not, it does this. We can only know what is true. We can know what is true. But we can, of course, we can believe anything. And we'll get to that. That's just one of my tag phrases. All right. So we're talking about epistemology. We want to get into epistemology because we want to understand how we know things, what we can know. Because if we're aiming after truth, we don't always hit it. That much is obvious enough. And we're going to use probability, not always in its quantified form. Not all probability we'll see can be quantified, but a lot of it can. And that helps us understand exactly what probability is. Last week we looked at logic. And we use logic to prove that probability is a branch of logic, and we'll do, more in-depth proofs of that when we get to it. All right. It's not possible to doubt. It's not possible. We're not going to go into this too much because none of us, I think most of my audience don't follow this line of thought. But I have a nice little quote in here from David Stove too about how we all can't be hallucinating or illusions or anything like that. It's just not logically possible. All doubt terminates in our sense impressions. Peter Kreeft, this is Peter Kreeft, the philosopher Peter Kreeft. He says, as Aristotle showed, again Aristotle, all backward doubt terminates in two places. Psychological indubitable immediate sense experience and logically indubitable first principles, such as X is not X or non-X, the principle of non-contradiction. Well, what is the principle of non-contradiction? This is a good one to start with. A is going to be some proposition as we had last time. Not A, cannot both be simultaneously true. Either A is true or not A is true. They can't be based on the same evidence. Based on the same evidence. Aha, what's that mean? Well, we'll come to that in just a second. They cannot, based on the same evidence, be simultaneously true. It is not possible to doubt this. It is not possible to doubt the principle of non-contradiction, that something can be known to be true and also known to be false at the same time. You can claim, a lot of people claim that they believe that this is doubtful, but nobody really believes it in real life. It's just one of these academic problems that people create for themselves. You ask a professor who doubts about truth, and then tell him his parking pass is expired and it can no longer be used, and you'll suddenly learn from this skeptic just exactly what truth is. Well, the principle of non-contradiction. That's an easy one to see, but we need to get a little bit deeper into it. So now we're going to talk about something I think is extremely important. Extremely important. One of the most important things we could do, because it's going to turn out all knowledge is conditional, all probability is conditional. And so that leads to the idea that there are necessary and conditional truths and necessary and conditional probabilities. So let me write that up. Necessary versus conditional. A necessary truth is a truth that cannot be disbelieved. A necessary truth is a truth that is true because it's the way things are the way things are. The way the Lord created the universe, or if you don't believe in that, it's the way the universe is, and it cannot be doubted. There are necessary truths. There's a fund of them in mathematics, as probably most people would agree. Conditional truths, however, are even more common. There's an infinite variety of these, and we use these in every day. So let me give you a good example. just to make sure that dumb thing stays away. Let's use a logical argument like we had last week. If x, y, z are natural numbers, and we have, make sure I quote myself right, x greater than y greater than z, and then we have x greater than z. Okay, so here's our list of premises. And always remember, we always have our premises on top. We're accepting this. We're accepting that x, y, and z are just some natural numbers. We're accepting that x is larger than y. And we're accepting that y is larger or greater than z. And from this, we can conclude with certainty that x is greater than z. This is a conditional truth. It is conditional on these premises. It's conditional on these premises, and if we remove some of these premises, it's no longer going to be the case. For instance, we can't just take two numbers, x and z, any two numbers everywhere in the world, and have that x is greater than z. It's not going to happen always. So this is a conditional truth. It's conditional on these premises, and if we change some of these premises, why then we have a different conclusion. The conclusion may be false. The conclusion may be uncertain. The conclusion may be anything if we change these premises. So, well, now the principle of non-contradiction, which we did, a proposition cannot be true and false simultaneously based on the same evidence, conditioned on the same evidence, given the same premises, accepting the same assumptions. All of those are the same way of saying the same thing. So now that starts, like all arguments start, which we're going to learn in more detail. I'm not going to go on about it today, but we're going to learn in more detail when we talk about intuition and intellection and induction, that all arguments are conditional. They may come down to sense impression. They may start at sense impressions, but those sense impressions and the logic we use to build them together to come to universal beliefs and logic and so forth, and to come to necessary truths, those things, we have to understand how they come about. We have to understand how they're a higher form of thinking than logic and all that. We will come to that. So for right now, we're just going to press on. Now, there's lots of, and I'll give you one quick example. Just one quick example before we move on to this. One which you know, just to give you a little bit teaser. We say for all numbers, all natural numbers, if x equals y, then for all natural numbers, if x equals y, then y equals x. It's obviously true, right? This is an axiom in arithmetic or basic mathematics from Pino. It's a belief. You believe that this is true, and it cannot be proved true. You cannot check this for every number. You cannot check. You could check it for a good number of numbers. You can go 1, yeah, that's true for 1, 2, 3, 4, and so on. You can go all the way up to, but you can't go out to infinity. Nobody can do this. We have to believe that this is true. It's obviously true. I think it's true, but you can't prove it's true. So empiricism is out. Empiricism is the idea that all statements must be verifiable by observation or something like this. We cannot verify this observation upon which all of mathematics is built. But however, we believe it because it seems to us obviously true. So there's our intellects, there's our intuition, there's our induction and action. And remember, induction is not of one kind. There's at least 5, we'll get to them, different kinds of induction. And so we need to be very careful about which kinds when we come to it. Okay. All right. Now, we need to understand how scientists talk and how they toss around theories and so forth. And I'm going to use another equation. I'm going to erase all of this. Again, talking about the difference between necessary and conditional truths. A necessary truth works like this. We'll have a bunch of premises or arguments, premises 1, premises 2, premises 3. We have all these different premises, n of them, however many there are, and some conclusion. The conclusion is conditionally true based on these premises, given these premises, accepting these assumptions, however you want to say it. And to make it a necessary truth, each of these is also necessarily true. A necessary truth, a universal truth. This may be a sense impression. It might start out to be if x equals y, then y equals x. In fact, this is exactly how mathematical theorems are proved. We start with these axioms. Now, you got to be careful in math because some axioms are obviously universally true, necessarily true, and sometimes people will use the word to mean this is what I'm accepting, where they don't necessarily believe it. There are branches of mathematics in which they do that. We're not going to get into that kind of stuff for us today. We're saying if this is a necessary truth, which I think it is, then we have another necessary truth, which we can supply. And we have 3, 4, 5, we have n of them. And finally, we deduce this conclusion, which is also a truth. And if all of these are necessarily true, and the implicit premises that we have, there's always implicit premises, which tells us what the word if means, what the symbol x means, what the double horizontal lines mean, what this comma mean, all that stuff, the definitions and the grammar, and any other implicit premises we have tossed in there. If all those are true, necessarily, then the conclusion is true. Now, scientists will have this habit of saying, well, we now know, you'll hear this all the time, even from people who don't know. They say, we now know, I use the example of Flippenberger's theorem is true. Okay, well, here's Flippenberger's theorem. You can prove it by following these steps. Okay? There'll be somebody else who hears about this, and he says, yeah, I think these guys are right. I think Flippenberger's theorem is true. But he hasn't gone through these steps, and in fact probably cannot. Not everybody, I can't do all these mathematical proofs. Who's got time to sit down and read all these mathematical? There's so many papers that come out nowadays, nobody can get through them all. It's impossible. It's just not possible. It's not physically possible. Nobody has this kind of a time. So somebody else may reason like this. Well, let's have a couple of other premises to make an important point. This premise might be that I heard C is true from experts. And second premise is experts always right. We have the same proposition at the end here. We have, it's true. We've proved it's necessarily true. We're supposing we've proved this necessary truth. But we have somebody over here who doesn't understand these premises over here, doesn't follow them. But he also believes, because he has accepted these premises. I've heard that it was true because I heard it on NPR or something. And I think experts never lie, or they're not wrong, or they can't possibly be mistaken. So to this fellow who thinks this, C is a conditional truth. It's a local truth, I should say. I'm giving him the wrong terms. I want to call this a local truth. All truths are conditional. This is a local truth. It's local based on these premises. Whereas over here, it's necessary. It's a necessary truth. So the same proposition can have either be locally true or necessarily or universally true. So we don't know. We don't know until we examine the premises, until we examine the argument. Here's another thing that tells us. We do not know, when we're talking about knowledge and logic and so forth, why it is that C is a necessary truth. We can explain it to ourselves. We can understand. We can say, we can come to an understanding why C is true. But we don't know why it is true, how it is true, what cause. This is another teaser. So for instance, pi equals 3.14 and an infinite number of numbers after that. There's all kind of formulas, which we'll get to. As a teaser, we'll give you some examples of these kind of formulas that we can come to pi. We can prove to ourselves the value in this same kind of way. But why pi has to be this value and not in the 18th billion digit, which is a 7, is instead a 6? Why? Don't know. We don't know why it's the case. All right, we don't know why, how the universe was created such that this is the case. And so we have to be careful about this. We have to be very careful about this for the next reason. So let me, I trust that you have all this. I don't hear any questions, and I can't see anybody's mystified face, nor can I see where somebody put the chalk, or the eraser rather. Okay, I found it. Let's talk about how all this fits in with science. What's it have to do with science? There's all kind of propositions in science like this. The speed of light is c. There's all kind of propositions like this. The speed of light is c. The atomic weight of radium is r, whatever it is. Sometimes they'll call these things, some physicists will call these things, maybe radium's not, but the c definitely is, constants. I think parameters, which is which is also in use. I think it's a better word. It's a parameter. We don't know why the speed of light is c. That is to say, there does not exist an argument with premises 1 that's necessarily true, premises 2, and so on, that comes to, I'll call this proposition A. We can't deduce the speed of light. It's experimentally given, all right? So this is a contingent truth. This is another way to say these kind of things. It's contingent. It's contingent on the premises, the argument that we bring to them. We don't have a strict deduction of it. If we did, it would no longer be a parameter. For instance, there may be an argument that gives us the atomic weight of radium. The periodic table is such like this, and we can deduce elements that should be there, and that's how some elements were discovered and all this kind of a thing. So the idea in science is to try to remove as much contingency as possible. In other words, to make these premises in our arguments as close as we can get them to necessary truths themselves, like mathematics. So that in mathematics we have all sorts of necessary truths as premises, and we just build on that and we see what follows from it. In science we can't often do that. A lot of times it's just reliant on observation. We have these contingent operations. Okay, so the better the science is, the more the sounder it is, the less contingent it is. The more it's relying on necessary truths. On the opposite is also true. The more contingent it is, like we're going to see with ad hoc probability models, which swamp certain fields like sociology, any of the so-called soft sciences, the cellar of science, and so forth. Well, they rely on all these ad hoc models. I'm not going to I don't want to insult anybody unnecessarily. Necessarily, I would like to insult a lot of people. But for right now, I'll just leave it as that. The more ad hoc we become, the more we just make up premises. I think the model is a normal model that looks like this. Well, that's highly contingent and in no way certain. And so that we just, if we have a bunch of questionable, question 1, questionable 2, premises, questionable M, and we have some conclusion, call it B. I hope you can see it. This is questionable and this is questionable. We did this last week as the homework, and this is questionable. Well, then the conclusion has to be even more questionable because we're building question upon question upon question. Of course, it doesn't work that way in the university's PR office and so forth. This is presented as just as sound as a mathematical theorem or something like this. So we have to be very careful. I think I want to leave us with a quote. This is all we're going to do today. I want to talk about Scientism. I'm going to talk about Scientism again and again and again. We're not trying to be good academics here. We're not even trying to be good scientists per se. What we're trying to be is trying to be people who understand the way the world works to the best of our ability, and not beholden to any given system or anything like this. We're trying to figure out what's going on, what truth is, okay? Or what things are, not what truth is so much as what things are true, what things are false, which are uncertain. Okay, so Jacques Berzon said that about scientism. He said, scientism is the fallacy of believing that the method of science must be used on all forms of experience and given time will settle every issue. That leads to different types of scientism, which we'll talk about. But the most pleasing one to me is Pascal. This is Pascal. He said, and I'll leave you with this. I don't have a homework for you. Unless I can think one up, I'll put it on the blog in writing. I can't think of something except to read all this stuff. Read the material I'm going to give you because it's going to be crucial. We're going to go from here. We're going to talk about faith. We're going to talk about the difference between belief and knowledge. And then we're going to go back to logic. We started with a teaser of logic. We talked about all this. Now we have a firm foundation that yes, truth exists and so forth. And we're going to go back to logic. And then from there, we're going to move on to probability. It's going to be a couple of weeks before we get to probability. That's the juiciest subject. But because it's so contentious, the foundations of probability and the interpretations of probability are so contentious, we need this absolutely firm foundation before we get there. So the things I say about it will be understandable in that context. Anyway, here's Pascal on scientism. He said, the world is a good judge of things. For in its natural ignorance, which is man's true state, the sciences have two extremes which meet. The first is a pure natural ignorance, in which all men find themselves at birth, and a long time after. The other extreme is that reached by great intellects, who, having run through all that men can know, find they know nothing. And they come back again to the same ignorance from which they set out. But this is a learned ignorance, which is conscious of itself. Those between the two, which Pascal, he didn't invent the term midwit, but Pascal was the first who defined midwit. This is the definition of a midwit right here for you. So Pascal and midwittery. He said, those between the two extremes at birth and the conscious ignorance, the Socratian ignorance, if you like, those between these two who have departed from natural ignorance and not been able to reach the other, have some smattering of some vain knowledge and pretend to be wise. These trouble the world, and they are bad judges of everything. The people and the wise constitute the world. These despise it and are despised. They judge badly of everything, and the world rightly judges of them. All right, thanks for listening. Next week, on to faith and belief versus knowledge. See you next week.